Hi, you guys. Today we are going to be talking about a third type of number called rational numbers. So this is lesson 3 of chapter 8. So earlier we talked about integers, which now includes positive and negative numbers. And then this week we are introducing rational numbers. And so whole numbers, we're just plain positive numbers, including 0, like 1, 2, 3, 4. Integers, -1, -2, plus the positive numbers. And then rational numbers now include fractions and decimals. And so if you look at your vocabulary section, integers, fractions, and decimals make up a set of rational numbers. A rational number is a number that can be written as a over b, where a and b are integers and b does not equal 0. So what that means is basically a rational number is any number that can be written as a fraction. So for example, 1/2 is a rational number because it's written as a fraction. But at the same time, you could do 0.5, it's a decimal, but that can be changed into a fraction. But that also includes numbers like, I don't know, 4. Because even though 4 is a whole number, 4 is equal to 4 over 1. And so that's true for all positive numbers and all negative numbers. Okay, so the first thing we're going to do is just practice graphing different rational numbers. You've all graphed fractions and decimals before, but now we're also going to be including negative fractions and decimals. No need to freak out though. Okay, so it says graph each number and its opposite. So I'm going to put them on one number line. Going to put 0 in the middle. Positive numbers going to the right. Negative numbers going this way. And when I graph fractions and decimals, I kind of just estimate about where it goes unless I need to make it more specific. So in this, for letter A, when it asks me to graph 3/4, I know that 3 over 4 is not 1 whole yet. I know it's somewhere in between 0 and 1. But I also know that 3/4 is a little bit bigger than 1/2. So I know that 3/4 is going to be roughly right here. If you really wanted to cut that area up into fourths, you could. And you could say this is 1/4, 2/4 are 1/2, this is 3/4. 4 over 4 would be equal to 1. So that's how I know that 3/4 is right there. And when it says graph its opposite on the number line, again, when we're talking about opposites, it means the same number of spaces from 0. And so on the other side, I know that the opposite would be -3/4, and it would be right here. And I know it's right there. You could draw little lines again to represent fourths if you want. Or if you know that positive 3 over 4 is in between 0 and 1, you know that negative 3 over 4 is also going to be between 0 and -1. They're kind of like mirror images on either side of 0. Okay, so then -1.6. I'm going to do it in blue. So I know that 1.6 is pretty close to 1.5, which is 1.5. So I know that my number here is going to be in between -1 and -2. It's going to be slightly past the halfway point, so I'm going to put it right here-ish. The opposite of that, it should mirror on the other side. And even I mean, you could do the positive side first if it's easier to think like that, but it's going to be right about here. When I graph negative and positive decimals and fractions, again, I just kind of estimate using some of my kind of logic or reasoning skills about where it's going to be. So you guys pause here and try the try it questions, then come back and chat. So the try it questions say graph the number and its opposite. You can use the same number line. So I'm going to just draw a really big number line. It looks like I'm going to have to go up to 6 on each side. When you go to do your assignment on Clever, I'm not sure exactly how they're going to have you mark each number on the number line. I don't know if they're going to have every line marked or if you're going to have to count yourself, which it might be easier to do these on paper first so you know what you're looking for. Okay, so there's my number line. So number 1, we're graphing each number and its opposite. I'm going to first graph in purple 2.5. So 2.5 is an easy positive number. It's right in between 2 and 3. Its opposite then is going to be like a mirror on the other side of 0. It's going to be right in between -2 and -3. That would be -2 and 1/2. Okay, the next one, -4/5. If we kind of think logically here, 4/5 is 1/5 away from being 5/5, and 5/5 would be equal to 1 whole. So if I want to guess, 4/5 or -4/5 is going to be pretty close to 1 whole, but it's not quite. Same thing on the other side. Its opposite would be +4/5. Okay, -3.5, which is equal to -3.5. So I know that 3.5, like in the positive numbers, is right in between 3 and 4. So the same is true for negatives. It's going to be right in between -3 and -4. Its opposite would be right here at 3.5, +3.5. And then the last one, 5.25. 5.25 is 5 1/4. It's going to be just over 5, but not quite to the halfway between 6. I'm going to put it there. The opposite of that would be -5.25. So a little past -5, which should be right there. Okay, so that was just marking things on your graph. Now we are going to talk about comparing fractions, comparing decimals using the greater than and less than symbols. Okay, let's go down to example. Oh my goodness. Example 2. It says compare -1/2 and -3/4. When we are comparing, I probably should have typed that, but we are talking about if the number is less than or greater than. So we are asking ourselves, is -1/2 less than or greater than -3/4? If you can kind of just figure it out right now without a number line, that's perfectly fine. If you need a number line, go ahead and draw one. It doesn't have to be huge. Put 0 here, +1, -1. And then if I want to grab -1/2, I know that +1/2 is right in between 0 and 1. So I know that -1/2 is between 0 and -1. And then if we think here about -3/4, I know that +3/4 is closer to 1 than 1/2. So I know that negative 3/4 is probably going to be closer to negative 1. So blue was negative 3/4, and this was negative 1/2. Okay, so then if you think back to what we talked about with integers, we said that numbers that are farther to the left on a number line are less than the numbers on the right. So if we write this like this, I know that negative 1/2 is greater than negative 3/4 because negative 1/2 is less negative, or it's on the right of negative 3/4. And then the same is going to be true for letter B. If we think about our number line here, these are only talking about negative numbers between -4 and -5. And so if you want, your number line only has to go to -4 and -5. If you want to get really specific, you could count it 6th. So you could do, this is -4 and 1/6, -4 and 2/6, 3, 4, 5, and that would be -5. So the first one, -4 and 5/6. So -4 plus 5/6. 1, 2, 3, 4, 5 would be here. And -4 and 1/6 would be right here. And so you, based on our integers, again, numbers to the left are less than. And so if you're comparing -4 and 5/6 is less than -4 and 1/6 because it's further to the left on the number line. So you guys try 5 and 6 real quick. Okay, so here is 0, here's -1, here's +1. -2. Okay, so for the first one, if we're talking about sevenths, if you want to count the sevenths again, you would count, this is 1/7, 2/7, 3, 4, 5, 6, 7 sevenths is equal to 1 whole. So you don't really put a mark there because it's already marked with the 1. So -1/7 would be right here. -4/7 would be 1, 2, 3, 4. So -4/7 is farther to the left, so I know that it is less than. Number 6, -1 and 2/3 and -5/6. If you notice right now, they do not have common denominators. So if you're getting exact on your number line, you need to have the 2/3, you need to change it to 6ths. So to change it to 6ths, we're multiplying by 2. So this would be equal to 4/6. And then this would be 1/6, 2, 3, 4, 5, and then 6/6 would be the whole again. So -1 and 4/6. 1, 2, 3, 4. -1 and 5/6 would be here. So it's just slightly less than. So I know that -1 and 4/6 is greater than. Okay, that's fractions. I know that some of you are going to instinctually just kind of want to put or turn all of your fractions into decimals, I would just go ahead and leave them all as fractions. But that's me, I like fractions better than decimals. Okay, comparing decimals you might think is a little bit easier because you can kind of think of decimals like money, and the numbers after the decimals are like your change, how many cents you have. So for letter A, if we're comparing negative 2.3 and negative 1.5, it's like you're comparing $2.30 and $1.50. And so on the number line, since these are both negative, I'm only going to put negative numbers here. So negative 1.5, which would be negative 1.50, which is negative 1 1/2. So it would be between 1 and 2, right there. And negative 2.3 would be negative 2.30. So not quite halfway, but in between 2 and 3. So based on this, I know that negative 2.3 is farther to the left, which makes it less than negative 1.5. And then for the letter B, now this would be negative 3.08 and 3.8. If you want to make it 80, you can. So it's like $3.08 and $3.80. Negative 1, negative 2, negative 3, negative 4. Okay, so negative 3.08. If you think of it in terms of money as your 8 cents, that's really, really, really close to $3. So it would be right here-ish. And then negative 3.80 is a lot closer to 4. So it would be closer up here. And so using this, the blue dot, negative 3.8 is less than, because it's farther to the left, but since you're writing this one first, you would say negative 3.08 is greater than negative 3.8. All right, go ahead and try the triads. I'm just drawing my number lines. Okay, so the first one, negative 0.5, and 0.3, that's positive. So automatically, you probably didn't need to draw the number line. Negative numbers are always less than positive numbers. The second one though, two negative numbers, negative 6.5, which is 6.5, so literally right in the middle of 6 and 7. And then I know that negative 6.75 is closer to 7. So it would be there. So I know that this dot is greater than because it's farther to the right. Okay, last couple. Oh no. Okay, example 4 says a Chinook wind is a warm mountain wind that can cause rapid temperature changes. The table shows 3 of the greatest temperature drops ever recorded. On which day did the temperature drop the fastest? So the numbers in the table, those are telling you the actual change in temperature. It's not like you need to find the change in temperature. And so if you think about this on a number line, they're all negative, so I'm going to put 0 here, negative 1, negative 2, negative 3. Yes, I'll put 4, negative 4. Okay, and then real quick, graph them. So negative 3 and 1/10. 3 and 1/10 is after 3. so it would be here-ish. -5/8 is over 1/2, because I know that 4/8 is 1/2, and so I know that it would be in between 0 and -1, a little over halfway, so maybe right there. And then, here I'm color coding. The last one, -2 1/5, would be just past -2. So which day did the temperature drop the fastest? I would say the purple dot, so because it is farthest to the left. So the temperature dropped the fastest on January the 10th, 1911, because -3 1/10 is farthest left, which means it's the smallest number. Okay, you guys try the next couple. It says number 9, you and your friend rappel down a cliff. Your friend descends 0.11 mile and then waits for you to catch up. You descend, and your current change in elevation is -0.12 mile. How have you reached your friend? So if you think about this, going down, here's 0, which would be like the ground, and you guys are going down. Descend means going down. Here is let's say 1 mile, which would really be -1 because you're below the ground. And then it's up to you guys. You can think which one is closer to 0, which one's higher up, to decide which one is smaller, which one's farther down, or you could literally count out where this would be. It's up to you, really. If you want to make little tick marks for each place, you can. Although I'm just gonna estimate kind of here that here would be -0.11, which would be your friend. And if I kind of think as I'm going toward -1, your decimal, it looks like it's getting bigger, like the numbers itself, but 0.12 would be a little bit past that. And so have you reached your friend? Yes. Technically, you've passed your friend. I passed because you're at a lower elevation. Because -0.112 is less than -0.11. It's farther down on the number line. Or if you made it horizontal, it'd be farther to the left. The last one, the table shows the changes in the value of a stock over a period of 3 days. On which day does the value of the stock change the most? So this is like example number 4 that you guys did earlier. We make a number line real quick. Here is -1. I know that day 1, like if I know that this is -0.5, and I know that, let's say this is -0.4. I know that this one is going to be halfway between the two purple dots. And then day 1, day 1 is a little bit not smaller. Well, technically a little bit greater than that. And so which day did it change the most? Day 3 because the blue dot negative 0.45 is farthest from 0. So you guys don't let this discourage you. It can be a little confusing sometimes, but I think you guys, if you use all of your knowledge and skills about fractions and decimals, I think that you can figure it out. But if you have questions, let me know, and thank you for watching.